So here's our CSCI 465, our smart security. Okay, so for this we're going to cover more advanced, but the first attack technique in like in IoT. Okay, so when we talk about what's the attack surface, okay, what's the possible. So for the advanced, we'll talk about the APT. So it's the advanced persistent threat in IoT, and also we have the called the zero days vulnerabilities in the IoT devices, and also exporting and IoT devices like maybe the exploitation, voltage, or cyber warfare. Okay, and of course, we also will cover overlap a little bit about the attack surface expansion. Okay, this we talk about maybe some like impact, extend a little bit about the edge computing or some like AI when we talk about the AI before, and then we'll move on about some security risk of some new IoT technology. Okay, so we are going to introduce, so especially the edge computing. Okay, and there's a penetration lab I giving you. So or also the net traffic sniffing using the wireshark to identify the attack vector. But for this part, I will let you to do that if you're interested and want to know more. Then you can follow the lab session. Okay. And as a beginning, so when we need to introduce what's the advanced IoT tech. So what makes this IoT system as a target for this that we always talk about this, I mentioned, of course, the growth of the IoT. Because like when all the IoT devices, like when they go up, especially maybe the smart city, maybe a smart home, okay, even our health care system and also industrial, like most of the time when we give an example would be more like home, like personal related. Actually, in this industry, like especially the industry control system, is more serious. Imagine that if there's a factory, or sometimes you think about the factory producing vehicle, okay, they being attacked, so they will be like cause even serious. Okay, attack, okay, huge damage. So all this will increase the number of attack vector. So okay, here's a reason. Then that's what we have to enhance the security. And also there's a lack of security standards. Like as we know, they always try to use the ease of use, low security. Okay, actually it's keep on improving. So but most of the devices like we're using for our daily life, let's say the router, if you remember the lab, we try to look at the framework, right? Bitworker framework. And actually they're improving, they try not to, like when nowadays they are not using the called the default admin and password, but they prefer like set up. So when you set up the account, maybe you can still use the admin account, but they request you to input the password. Okay, so once you input the password, then that one will store. So you couldn't like compare with the old firmware and new firmware. So old firmware, they will store the default password. For new firmware, they will ask you to input the password. So that's why it's increase the difficulty. Also, sometimes outdated firmware. You know, most of people once they install it, and if that device like execute for maybe 5 years, then they never update the firmware. So it's a good practice. We say like try to improve it, right? Upgrade the firmware. And then what is the with the renewable, like why IoT is always we say limited, because right here most of the consumer devices. So we're like low cost, okay, then they're minimum the processing power. So therefore, the lack of robust security measure. And we talking like if at home like smart control device, like the smart light bulb, thermostat, so all these, because they want to control the core, so they are not like include lots of like hardware, okay, chips away. And also for the unsecure communication, or sometimes when they implement, they didn't really they didn't use some secure. So those like communication will be really risky. So they maybe use the HTTP instead of using HTTPS. Okay, actually now they even you purchase maybe a router, sometimes they will giving you by default as a HTTP. But if you're more advanced, something like that, you know how to do that, then you can switch to HTTPS. But if they stay on the HTTP, then they're easy to expose data and those devices like to malicious actors. So it's the issue. And then also the supply chain issue, because those are third-party components. So such as like the microchips, there is the OS. So using in IoT devices, so they maybe also have vulnerabilities, so that the attacker can exploit it. So maybe they already try to enhance that by the security by like those like communication protocols. Okay, but if the microchip or the OS itself, the firmware itself, like also have a risk, then you easy or something like the backdoor. Okay, and also the exposure service. So if they're using certain service, let's say Telnet, okay, or SSH with some different credentials, so it's the easy become the target. So it's like we know they always open port 22 for SSH. Because for developers, sometimes like for users, sometimes I need the SSH. So how can we enhance the security? So here's the thing. Sometimes we use the key RSA. Okay, so this is something to increase it. And we talk about the APT, the advanced persistent threat. Okay, so what's it? So it refers to a series of highly target and multi-phase cyber attacks. So in which there is the attacker that seek to gain the unauthorized access to a system, or remain undetected over an extended like period to gather some like intelligence, support stage, or like manipulate the system. So here's the idea. We call the advanced persistent threat. Okay, and right here there's some characteristics that to like more explain the details about the APT. So first one is the persistent. We say the persistent. So the attacker, so the aim is to remain in the system for a long period without detection. Sometimes it really happens is that okay, first that we do have a session. Okay, so how can we remain session, or like how can we detect some in some like unrecognized, okay, and login. So all these like and sophistication. So all this will be more like the orchestrated by the some like well-funded or skilled actors, something like that, nation stage or criminal one. So with a syndicate. So all these will be doing this way, or the target attack. So they will target some specific individuals or companies, even countries. Okay, so they're highly like tailored attack. So they're aiming at some like critical infrastructure. So let's say if we know for the chips recently, okay, if the target on chips, so who are producing chips, okay, maybe you know the Taiwan, the one, okay, so or maybe the Texas Instruments, so all these like, and or if you are working on maybe let's say if you want to get the, like electric car, like how get the design, then you know like which one you're going to target. Okay, and we have the step. Okay, so right here, so is the technique. So just like encrypt this, the command and control, we call the C2 channel. So they can obfuscate the malware or some like multi-stage exposed to help the APT to avoid detection. So this is to avoid the detection by some like traditional security tools. So it's the idea. Okay, and as a first stage, so what they're going to do? So how can they start the initialization? So they choose to exporting something of property such like weak or default credential. So we try to looking for like Telnet or SSH in the IoT devices. And also we can use some like phishing techniques, okay, targeting those like device administrator or vendor. So we're sending emails, okay, and then we can leveraging the open source tool like MAP. So if you know MS, so we can identify those vulnerabilities. So what are the open port? Okay, so how can we connect to them? So this one is the idea as a stage one, and then in the stage two when we are moving, so we talk about the how can we stay there longer, right? So maybe they can try to deploy some like rootkit, if you will, a rootkit or a backdoor, so they can maintain a long-term access to the devices or network. Okay, because maybe one day if you realize that okay, so you know the port, or like sometimes you only open the port for certain service and later you can go close it, right? So as an attacker, they need to like keep it okay. I need to make sure I can always able to access to the device. Then I need to open the back door, or like I can use some other port. Okay, never use. Okay, so I can use it for myself. Okay, and also they can use the encrypted C2, channel, okay, including the DNS and tunneling HTTPS to send some command without the detection. So it's a second stage we're going to do. And moved on to the stage 3 with a little movement. So once they get inside, okay, attack has been just spread all across the network, okay, and then exploiting the alienable device and with network segmentation. So all this, because if I once I able to just imagine if there's a thief get into the house or break into a room, then you can go to other bedrooms or other location in your house like this. So here's the idea. And when they're using some IoT botnet, so they will move them like little across the devices in a network. Okay. So this one, like if you remember there's a case, so this are using a mirror type of malware. So this one is the example. So it's for doing for the IoT botnets. Okay. And after they able to do that, then they will move on to stage 4. Okay. So what's stage 4? Okay, so there is a filtration or exploitation. Okay, so this one we're trying to gather some sensitive data. So in this stage, finally they try to gather some data information or try to manipulating some control system or disrupt the operations or this. And we talk about the data, the filtration. So this one they will try to doing some corporate or some governmental or personal data from the IoT Connect system. So it's the idea. And then they try to use some IoT devices like as a launch pad. So they can perform so-called the border cyber attack. So even the DDoS. Okay, so they were doing in this stage. Okay, and that they steal all your personal information and then they would turn your device. Okay, so as a launch pad, so they can sending the mainly is the DDoS attack. Okay, and then right here when we move on, there's one of the example the next the worm. So it's a really famous example for the APG targeting. So it's like targeting for the industrial control system ICS. So it tries to spread through the PLC. So if no PLC, so using the our nation's nuclear threat city. So it caused a really physical damage to the equipment. So also while avoiding the detection for a month. Okay, for months. So you see, maybe in daily life you're feeling okay. Once I just imagine your thermostat. Okay, being attacked. Okay, and then you didn't realize it. So they would just like maybe if you want to turn on, but you never let it off. Okay, so and then or like if you want to turn it off, so they are not allowed to you to perform any action. Okay, like this. Okay, or the camera. Okay, so they will try to like steal your cameras. Okay, all those like videos or your voice. Okay, all this. And we also talk about the zero-day vulnerabilities, right? So in the IoT devices, and so for the 0 day, so it was referring to, so it's talking about previous like some unknown fault in the software or hardware. So they are not, has not been patched by the vendor. Okay, so the term is telling the 0 day. So to the fact that vendor had 0 days to fix the vulnerability before it explodes. So here's the idea. And why is so dangerous? The first one is that unpatched. Okay, so this is because they are unknown to the vendor, so it makes them really extremely dangerous to the IoT devices. Okay, and also for the long exploitation on Windows, so 0 days like can go undetected for months or even years. So it can create an extended attack window for attacker. And also we have a wide impact because all those devices, smart things devices, they are often connected to other systems. So no matter in the industrial network, our car platform, okay, and maybe your home, okay, so also connect to the car. So all these are single 0 day vulnerability can have a cascaded effect according the entire ecosystem. And for other system, like if we take an example, if you know, no matter Windows, like maybe Windows, they always allow the attacker, because when they or even just like Apple, okay, they just release the update. they have a new update, no matter they're Mac OS or iOS. Okay, so they have a new update. So sometimes they never test, or like nobody like reporting their issue, so they never like fix those the vulnerability. Okay, so and Windows sometimes they are welcome for some people like try to looking for some like backdoor. Okay, what's the risk, and then they can report to the Windows. Okay, so Microsoft, then they can the engineer can fix it, or sometimes they will encourage it and pay for those like who able to looking for those vulnerability and then provide a solution to fix it. Okay, so there's a this industry like for Windows system. Okay, but how about the in the IoT? But luckily, like when in this in this ecosystem still not yet I say mature enough, or like supporting or like encouraging developer like to explore, because they there's so many like if we have so many different type of smart things IoT, that means they running on different OS system. Okay, and there different firmware. Okay, so if we have to able to do this, then we have to build up a really strong community. Okay, to support it. Okay, and we talk about like the mirror botnet. So it's using the zero date, because we try to create a massive botnet, which they responsible like for one of the largest DDoS attack in the history. So we talking about this. So they use all the cameras, router, okay, all connect on devices, okay, and start from zero date, because the vendor they never know. Okay, so they really have to wait until really happen for maybe a month, and then they're able to realize it, and then they can give it like release the firmware somehow. But also as the follow-up, sometimes maybe they don't have an automatic update, so they need to have wait for the user customer to update firmware. If the customer didn't update, okay, then you still expose those vulnerability. Okay, so you're not yet fixed. So it's the dialogue. Okay, and also we have some common zero days attack. We talk about is the device firmware. Okay, when we did lab on Tuesday. Okay, so this one we talk. Also, we can have some like memory corruption. So issue in the firmware, such like buffer overflow, or cause some like format string vulnerability. So it can allow attacker to run arbitrary code. Okay, and also they have some like unprotected communication protocol. Okay, so maybe mainly like IoT devices, so they can use they will use the insecure communication protocol, let's say a mobile as HTTP. Okay, so this one exposed by the attacker to gain the control over device or manipulate the data in transit. Sometimes they thinking, okay, if they set the password and then have an account, they think, okay, they especially and maybe in the home network. Okay, so they think, okay, they install and the attacker cannot really touch it. So maybe when they connect with other devices, they maybe when for communication, they will just like stay on the HTTP. They thinking just for internal. Okay, but once they're able, the attacker can get into the like internet, like through some backdoor, some port, then you're pretty easy to explore. Okay, and also the weak authentication, as we know that default credential. So we always know, okay, even for other suite, there's a basic. So they always using the default password, and some like admin 1 2 3 4 5 6 7 or password or whatever like this. Okay, so it's a common vulnerability even right now nowadays. Lots of different devices like doing this way, and maybe for enhanced security. Okay, some vendor or like manufacturer, they try to modify, change the password to like random code. Okay, so when you look the attacker, so they can use some automated tools to guess this like credential and taking control. I think in the our NS class digital forensics over there, so we download the called the like guess the password table that file. Okay, so actually we can use this one to guess the password. So it's the same way. Okay, we can do it in that way. And also another one in 2016. Okay, the DOS attack. So it utilized the mirror botnet, also exploiting the zero-day probability in the IoT device, right? So like that one will be because the default credential in IP camera and DVR. Long time ago, because those like IP camera, so they were camera admin and then by default password, so like this. Okay, but lucky one now maybe improving. Okay, and another one we talk about in our APT. Okay, the exponential. Okay, and right here for those like devices, so maybe some smart cameras, thermostats, or like voice assistant, like some smart devices. Okay, so they can compromise to secretly to collect the data of record the conversation. Okay, so they will hear what you're talking and then perform some like surveillance on individuals or organization. So all these, and most of them you realize that okay, even your phone, like they will listen to what you're talking about. Sometimes when you try to browse something, search for something, they always like giving you some ads, right? So it's a wonderful idea. And another one is the supportage. So it's more like a more malicious form of the attack. So which like the attacker, so they can target the IoT devices. Okay, can cause a physical damage or disrupt the critical system that they trying to do. So they can mainly manipulate some industrial IoT device. There's an idea. Okay, or sometimes they try to disrupt the production line or some release some like hazardous materials. So that's like what they're going to do. And another one is the called cyber warfare. So this one is more like the nation state actor. So right here, so they can use the IoT device as a part of a large warfare. Okay, so they can infiltrating some critical national infrastructure. So this one is more serious, like maybe in the like, country's level. So um, it's more it's really hard to observe by yourself, like because but in maybe in a country like other country, and that's what they targeting. Okay, and not pet there. So this one attacked in 2017. So it target the Ukraine infrastructure. Okay, so it try to spread some like global and cause some massive disruption. So this doing so aimed to like sabotaging the critical national assets. So here's what they did. And then we move on to about the like edge computing. We thought the edge computing would be the pushing the data closer to the source, right? So the IoT devices. So rather than just transmit to the centralized data center or cloud platform, so it can help reducing the latency and also increasing the efficiency in real-time data processing. The idea just imagining for the IoT, or actually you when using the Raspberry Pi, right? Using Raspberry Pi, so Raspberry Pi can be the like we call the edge computing, and it connect to like different type of sensor. We collect data and store it. Okay, and when you after you process, and then you can send it to the cloud server, like maybe every minute, every day. So it was something. Of course, not only Raspberry Pi, but in industrial we have other devices that to perform this action. And what are the security challenge introduced by the edge computer? First one in the decentralization, because all these like distributed nature of edge computer, so will make the security like every node like much more challenging because all these nodes we cannot really control, and also it can increase the attack surface because they have more entry points. Okay, for attacker, where all these at the edge devices or not can become the attack vector. Okay, sometimes like we have to like target on the cloud server, so we have only one target. So here's the idea, and there is a pros and cons between the decentralization and then also the data leakage. So the data they process like locally, that means that they may be not always adequate encrypted. Okay, they may just save locally. So once being attacked, okay, well, already able to spreading or export to attacker, then they're easy to cause the data and breaches or this. Okay, and also the diverse devices because those like edge computing we say have variety of device. Giving some example, we're using Raspberry Pi, but for in the industry, maybe other devices. Okay, you never know, you never see. So it's have a different security posture and pattern cycle. So really hard to control. Okay. And maybe in the smart city, so all those that edge devices maybe control the traffic light, surveillance camera, okay, the street lights, all this, those that can be able to attack. So once they're getting control over those like edge now, so they can disrupt the city infrastructure, okay, and really create some like chaos like this, okay. We also cover about the like the AI, how can we use the artificial intelligence, like can use like maybe automation or like predictive maintenance or some like data analysis, so we can perform in um and helping the performance. Okay, but for this like helping for attack automation, so attacker also can use the AI to automate some attack, okay, to make them more effective, faster. Also some like AI driven like brute force attack, so it can guess the password, so it can make it more quickly than traditional way. Okay, and then also they try to poison attack, so they can manipulate the AI model, so using in the IoT device by feeding them of adversational data, so they're designed to corrupt the model or some overlay within on the AI, so they can using some AI for the anomaly like detection. They fail to detect the zero day, okay, and if the changing data they didn't could include the example of these new properties, so also it's possible. So you see, we may apply the AI on like enhance the security level, but for attacker they also can apply AI, okay, to take our IoT. So it's the two ways. So we need to like pay attention, and also maybe we can use the AI like in the smart thermostat, so learn the user performance way. So then we can be like hack to gain access. So we know the entire home automation system, and sometimes they're learning. Okay, when they are living. Okay, when they stay home. So all this, and also some like used in the healthcare device. So it can important to provide some inaccurate medical diagnosis is also possible, right? And we move on, and we are more like just like have one thing, more device and more risk. Okay, so the proliferation of the edge device is just like combined with the AI. So the increasing role and the expanding attack surface. Okay, right here. Especially when you talk about the like autonomous vehicle system. So the AI processes the data from the sensors, right? At the edge, somebody will say camera, the LDR is the sensor, like the radar sensor, to gain the objects like nearby. So when the attacker like compromise a single vehicle AI system, then they can potentially control multiple vehicle in the fleet or leading a serious safety risk. So here's the issue. And just like giving a scenario, they may be another scenario maybe the attacker can manipulate a small grid of AI to add to the power distribution. So based on the fault sensor data and got some outage like or the worse overloading a system to trigger the physical damage to a power infrastructure. So also they can do it in this way. So you see they in some purpose they are not really say, okay, I just attack, but also they can use like some based on fault sensor data and then cause the outage and then trigger some like even more the physical so damage. Okay, so it's like layer by layer. Okay, and also there's some, but also one more thing when we apply the AI, because AI model they need to learn and store the sensitive information like of the user. Okay, behavior or some like systems. Okay, all these record financial data, and also including the edge devices. So they often like process data locally. So in like we call the unregulated environment. And if I compromise, then those data can expose, okay, or like or misuse. So here's the risk like related to data privacy. And as we say, because it's getting more complex. Okay, so also we're more like unknown attack vector because they're really complex. They interdependence dependencies because the effort in one component can open up new vulnerability in entire system. In the traditional way, like traditional tool may be not really equipped to handle the unique attack vector by this like new technology or introduced. So it's like really harder than before. Also what's the probability that the risk in the AI model, because the model is the invention attack, so they may be used to reverse engineer, or we do the reverse the engineering, so to the AI models, so they can extract some sensitive data that was they used to train that. So and also some like invention attack. So for the malicious input data, so they can craft to mislead the AI system, so they can cause the misclassification or cause the results in appropriate decision. Here's the idea that you're thinking, okay, let's get a model, but if I give you some like really malicious input, then your AI model will give an incorrect output, right? So here's the also another risk, maybe in the health system, so maybe use some like wrong dosage of medication. So if they are using the AI algorithm, they mislead by the adversational like input, then cause some harm to the patient. It's also possible. And so far, like we quickly went through the lecture. Then just like let you know, we will work on some IoT attack. Okay, like use to like mitigate them. So using some penetration tools. So maybe you can use like Linux, Metasploit, or like Wireshark, and you can use it. And if you search and install it, and in the beginning you just need to set up at least, maybe if you have the Raspberry Pi, so you can use the Raspberry Pi, and then we can use the MAT. So if you remember, we introduced the MAT to scan the port. Okay, so where the open port and surface, so they're running. So this is just simulate discovering all those mobile devices on the internet, on the network. I already know it. Okay, and then the next step, so we need to find or expose some like no budget, some like called buffer overflow or weak password, so we can use the meta sport to gain the remote access. Okay, and then we can sniff the network traffic, so to use the Wireshark to capture and analyze the network traffic, and also we can looking for some potential man in the middle attack. Okay, and then instead execute the attack, so we can simulate the DOS. Okay, so just like sending the ping to the other server, so you can write a script like normally using Python and or like Node.js or C++, whatever, just like sending the ping request to those like. Okay, so mainly like for this lab, if you're doing so, you just think about like how can we do the encryption. So like in the device that communicate in the CAN test or the plain test, so they're easy to compromise. Then we are better to encrypt it, and then also the patch management. So how to update the firmware, and also how can we monitor and detect the network, so which can help us to detect those malicious traffic patterns. Okay. And so far, quickly, we just like as a just wrap up everything. So we introduced what's the APT. So it's the significant the threat to our IoT system. Okay, and also we talk about the 0 day. 0 day, even the vendor they have no idea. So and also so they can go like undetected for really long period of time. So like that's what the attacker will love it. And some we need to consider for some like new AI or edge computing. So it can create a more like attack surface. And like in one side, so it may be like more effective. Okay. And we can help for some like security solution. So if we are like properly implemented, but in the first side, but also it exposes more risk. Okay. Also try to perform more like secure practice when we're learning. So how can we enhance the security level by this stronger like authentication, encryption, also like have a regular patching or network monitoring. So all these ways can help. And so wishing you like it. And for the next, we have the multiplication tool, and this is just telling you how can we this knowing some way from the advanced first like APT 0 days. So how can we collect all this, like including the network segmentation? So we try to separate the IoT networks. Okay, so from the critical infrastructure, so they can limit the little movement. Okay, and also the implement some firewall and then the intrusion. Okay, and detection system IDS. So specific to the monitoring the IoT device traffic, and also we can help for the like using the doing the called the device like hardening. So we try to disable some unused surface or port, and also try to change the default credential, the password, and enforce the strong password policy and update the firmware. All this can ensure that also the boot process. All this can help, and always try to encrypt it. Okay, using a TLS SSL encryption or some improvement, something like end-to-end encryption for sensitive data. So one is the we call it in transit and at rest. Okay, so this is a two direction we need to do, and maybe we can implement some like a vulnerability management program, so it can continuously scan and patch the IoT device, and also we can work on some like zero-day threat intelligence. How can we subscribe to the threat intelligence feed and track some new vulnerability emerging the threat in IoT devices? So it may help, and also the some like AI and machine learning in defense, we can use some AI-driven anomaly detection, and also we can implement some machine learning model for some behavioral analysis. So we can automatically detect the deviations in the device behavior and prevent some potential exploitation like this. Okay, so of course, attacker we use the AI, and also we can use the AI machine learning to help us. Okay, to enhance the defense. And there's giving more examples right here, just to recap it all the case. Okay, you can, if you're interested, you can look at it and just think about the future, like so how always they would be AI powered attack, pretty sure. Okay, and then maybe the AI for the target attack, so they can identify some specific vulnerability in the IoT system faster, right? So we need to think about that. And also coming out, because we have the quantum computing, like quantum computing, and also it's the new topic we have to discuss. Right now we still don't have so many things to talk about, but maybe you really break the traditional cryptographic techniques used to secure the IoT system if we can use the quantum computing. And also later we have the like called the post-quantum cryptography. So in the future, maybe we can use it for the content resistant cryptography to protect against such threat. So you see, we can apply it. So it's like kind of two-sided. So we need to learn how can we use those technology, and how can we prevent those technology for attack. So we need to learn. Or also we talk about the blockchain. So we can use to ensure the immutable like data logs or secure the device communication. And we try to decentralize IoT system. So we use the blockchain, and also we can enhance the device authentication using biometric authentication, multi-factor authentication, MFA, or some hardware-based like security chips like TMP, HSM. So all this can increase the security. Kind of like last part. So in the industry too, like sometimes we normally talk about a lot about in the industry in this field, but for the industry standard more like the IoT Security Foundation or some like IoT cybersecurity framework, so it can give some provide some guideline for manufacturer to design secure devices and system. And so far to web, and this part for our advanced attack. Okay, related to the APT. Okay, thank you so much.